All right, guys, let's dive in here. We're learning our third way to solve systems of equations today. It's called elimination. Okay, that means there are three different methods you are learning and can use. Method number one, we had graphing. Method number two, substitution. And now we're going to look at method three, elimination. Good news. Number one, there's only three total methods. And number two, I think elimination is the best and most useful of them. So that's why I saved it for last. So you see the other two before you saw this one and learned them first. Because once you learn this one, you might just use this all the time. All right, random fact. Most elephants weigh less than the tongue of a blue whale. That just blows my mind. All right, moving on. Okay, this idea of using elimination to solve equations. So we've got x equals 3. I bet I just made some of you guys yawn, huh? And if x equals 3, then 2x must equal, yep, good job, 6. Now, let's think of that as its own little system of equations. X equals 3, 2x equals 6. It is a system of equations, meaning they go together, because in both of those equations, the x equals 3. That a value of 3 for x makes both equations true. So just like the other system of equations we've been solving in 2 variables, this one's just a system in 1 variable. Well, watch what happens. Watch this cool property if you have a system of equations where they both have the same value for x. What if I combined the 2 equations to make a brand new third equation? X plus 2x, well, that makes 3x. 3 plus 6 equals 9. And if x equals 3, that's interesting because it still works. X equals 3 makes that equation true. X equals 3 makes that true. And x equals 3 makes that equation true. So notice what we just did is if you have a system of equations with 2 original equations, you can add them. And the third equation is still valid. Now, why might that matter? Great question. Let's see. We just want to notice that principle right now. This problem right here is the one we're trying to solve today. That's the one we want to learn how to use elimination to solve, okay? Let's try this new principle that if you've got 2 valid equations in a system, we can add them up, and we'll have a third valid equation in that system and see if that helps. 3x plus, we're adding the whole set of equations, so 3x plus a negative x, 2x. And notice we're just adding straight down these columns. It's kind of like we went back to grade school, like 4th grade, and you're just adding, straight down the ones column, straight down the, tens column. We're just doing the same thing here. Because they're like terms, the way the 2 equations are written, I'm just going to add x's with x's, y's with y's, and then constants with constants. And I'm just creating a new equation because I'm making sure to add all the like pieces together. Negative 2y plus 3y, so that's just negative 2 plus 3, so plus y. And then negative 26 plus 25, that's just negative 1. Okay, so this is also a third valid equation, but it doesn't really help. I've still got both variables. I still would have to use substitution or graphing or something to solve this. So as of yet, that method didn't do a whole lot. Let's come back to that later and see if we can improve that. If we could figure out how to use that method on this one. We're still kind of stuck. I've got an idea though. Let's try this new idea. Let's rewrite these equations. 3x minus 2y equals negative 26 and negative x plus 3y equals 25. So we're just going to try again and see if we can work these out in a better way. There we go. Goodness gracious. All right. I remember in the past with you guys, we've had this idea of being able to multiply or divide a certain value through, like on a fraction buster. If we have something like this, remember with a fraction buster, if we want to bust that, we could multiply by 3 here. As long as we multiply by 3 on every other term, and then we end up with another valid equation that we can solve, but it doesn't have any fractions involved, okay? And the reason that works is because of the concept of this fraction buster. You're multiplying or scaling up every term of the equation, and you end up with a second valid equation, but no fractions. What if we apply that idea here? If I could get this guy to become a negative 3, then it would cancel with the positive 3x when I add the two equations together. So the question is, and this may seem obvious, but I'm going to write it out anyway. What would you multiply by to turn the negative x into a negative 3x? I know, really obvious. Hopefully you're saying, duh, Mr. A, it would be 3. And you're correct. So a couple things to point out. We want to use 3 here to multiply by because we want a negative 3x. Second, we want a negative 3x because we want something that when we combine it with this 3x cancels out. So we're trying to create an opposite pair between those two x's. If we have a 3x in one of the equations and we can create a negative 3x in the second equation, when we add in a minute, those would cancel out if that was a negative 3x. That would be really convenient. So what if we use this idea of the fraction buster and just change the equation? It'll still be valid as long as you do it in the right way. So let's multiply through by 3, and remember to do it with each term of the whole equation. If you want to do it in a way that looks like distributing, including the other side of the equal sign, you can write it that way. If it makes more sense to do the fraction buster kind of version of things by writing the 3 on each term, do it that way. But as long as you multiply each term by 3, it's going to stay a valid equation. So now the negative x times 3 is negative 3x. That 3y times 3 is a 9y. And the 25 times 3, 75. Now we'll just copy this guy down and see if now the combining, the eliminating might work. So let's add these two together. And hey, there we go. 3x minus 3x cancels out. Negative 2 and 9 leaves us a 7y. And then 75 and negative 26 would be 49. That's really convenient because now we're down to one variable. Why am I dividing off y? I want to get y. We're down to one variable, which makes it easy to solve. And then we would plug in that y value of 7 to either original equation and find out what x is. The key here is, what would you multiply by to create what I would call an opposite pair in your equations? Okay, opposite pair meaning they're just opposites of each other. 3x and negative 3x, or 10y and negative 10y, or 2x and negative 2x, whatever it might be. You just want to multiply by some value to create an opposite pair, and by so doing, the elimination, when you combine the two equations, you'll eliminate a variable, and you can easily solve for the remaining variable. Let's do it again. Okay, what about this? Let's try this problem with that exact same idea. Now, it's just a system of equations, and again, notice before we can use it, make sure all your terms are lined up correctly. Like here I've got all my x's, here I've got all my y's, and here I've got all my constants. Okay. If you happen to get an equation where things aren't written in that order. Maybe this exact same systems of equations comes written like this. Notice all I did was switch the position of the x and the 2y up here. Right now they are not in an order where you can combine them because your x's aren't lined up. You would need to rewrite the top equation so that they are lined up, and now we can apply this idea and go straight down the columns, x's, y's, constants, and notice these are written in standard form, these equations, with x and y on the same side. This idea works how, whatever form they're written, but most of the time you'll see standard form. It's kind of the easiest way to think about it, so just kind of default to that. You can go x, y equals the constant, and that'll just make it easy for you. So x minus x, oh, those cancel out. What's going to happen here? Then 2y and negative 4y, well, that's just negative 2y. And 8, remember we're adding here. 8 plus negative 18, well, that's just negative 10. Well, that actually improves things because this new third equation that we created from the original 2 when we added them, it's only got one variable. And hopefully you're looking at it right now and going, well, that's really obvious that the y has to equal 5. Just solving the one step that's left there after we combined makes it really easy. Y equals 5. And from here, I also hope you know what you're doing at this point. Take either original equation, and once you get one variable, plug it in to either of the originals and solve for your other variable, okay? And this part isn't any different than we've been doing. So plug in right there, so we're going to have x plus 2 times 5. Plug in the 5. We replace the y with 5. So now we've got x plus 10 equals 8, and we're just, thinking 10, writing 8. We're just solving for x, which is negative 2. So my solution to this guy was negative 2 and 5 for my x and y. And it turned out that it became easy to do because when we combined, when we did our elimination method, what was eliminated was the x's. When we added the two equations together, it canceled or eliminated the x variable, leaving only y variables, which unlocks our ability to solve. We're down to one variable, so we can solve for that one variable. It would be nice. All right, here we've got 3 sets of system of equations problems, and these are just practicing the idea of creating the opposite pairs so we can get them to cancel, okay? Opposite pair, remember, is going to be like the exact same value, but one of them's negative, so positive and a negative of 7x or 8y. So let's look at problem 1. I'll work through these, and you guys can kind of watch and get the idea. If I look at these problems, I'm going to notice with the y's, 5 and 15. 15 is a multiple of 5. So if I multiply 5 by 3, I'll get 15. And since their signs are already opposite, what I'm going to need to do is multiply by 3. And I'm trying to cancel the y variable, okay? I'm writing this out just so you guys can kind of see what's going on in my head. This is what you want going on. So I'm going to cancel the y variables by multiplying by 3 here. So I'll show it in kind of a distributing way this time. 3 times negative 5, that's negative 15y. 3 times the negative 2, negative 6y. And then 3 times that 14 is 42. Now I'll just copy down the other equation. It was a positive 15y minus 5x equals 18. And notice what's going to happen here. When I add the two together, because these guys are opposites, they're the same value, but one's positive, one's negative, a negative 15y and a positive 15y, they're just going to add to nothing. They're going to cancel each other as good guys and bad guys. Then I've got negative 6 and negative 5, which is negative 11x. 42 and 18 is 60. And now you can solve your one step. Just divide off the negative 11. that one won't come out to a whole number. That's okay. We're not going to finish this system. My goal here is simply to get you guys understanding this concept. We want to see that the 15 is a multiple of 5. Therefore, I want to multiply with 3 to create that opposite pair that cancels. Let's try the second one. I'm going to look through here, and I'm going to notice, first off, the x's do not make a multiple of each other. I can't multiply 3 and make 4, so the x's are not going to be my first go-to. I'm going to look at the y's, again, just like the last problem, and the negative y, if I multiply that by 7, it'll become a negative 7y. But notice I need the signs to be opposite here. If they're both negatives, they won't cancel. So I need to multiply by 7, but I also need to multiply by a negative with the 7, so it'll switch that sign. So I'm going to multiply everything in that top equation by negative 7. Okay? So 21, negative 7 times that 21, what's that, 147, so negative 147. So I'm just multiplying this negative 7 through everything on that top equation. Okay, that's what I just did. The negative 7 times the 3 is negative 21x. And the negative 7 times the negative y is going to be a positive 7y. Now I'm just going to copy down the second equation. And we can see the whole purpose was to be able to combine these in a minute and get a cancellation. Positive 7y, negative 7y will cancel. The negative 21 on the 4 is going to be a negative 17x. And then the negative 147. Remember, this whole thing is a big addition problem of the two equations. Negative 147 plus negative 9, negative 156. And I don't know if that'll come out to a whole number. This is just a practice problem to do this first part. But we can see how easy it is to solve for x. I don't know if 17 will go into 156, but you get the idea. Okay? And again, what I want you to notice is we looked right here to realize multiplying a negative 7 is going to create this opposite pair, the elimination we need, and now we can solve the system. Let's do it one more time. Okay? And you guys feel free to jump ahead of me. Look at that problem. What are you going to do? Now, first thing to notice, this one is standard form. It's x, then y equals the constant. The top equation is not in that form. We need to move things around. We want it to have the y in the same position. We want that constant moved over here so our equations look the same. So when that happens, you got to first rewrite it. So negative 3x. And remember, to move something across the equal sign, you're just canceling. So you're just changing the value sign. So that 4y on the right will become negative 4y on the left of the equation. That minus 6 to move it over would just be an add 6. So it becomes positive on the other side. So the first thing I did was rewrite it. Not to create the opposite pair, but just so they're both in standard form, just so we can now look at the problem. And now we'll look at it and we'll say, okay, right here, my y's look like an easy go-to. I can multiply by what? Hopefully you guys are saying positive 2, because I need that negative 4 to become a negative 8. And then they'll be opposites, negative 8, positive 8, they'll cancel. So let's go ahead and do that. We would multiply this whole top equation by 2. So 2 times negative 3, negative 6. And you know what I'll do? Let's see if I can do this without confusing you guys. I'll just write it right here. Negative 6x. 2 times the negative 4, negative 8y. And then 2 times the 6 equals 12. Okay, so now that I've rewritten the equation right to here, I'm just going to add them without having to rewrite again. Okay, so I rewrote the blue equation as green, and so my original system is now the red equation, and the green one after I rewrote it, and now I can look for elimination. The plus 8y minus 8y, they cancel. The 8x minus 6x leaves me at 2x, and 9 plus 12, 21. And again, I've now eliminated the y's. I've got only the x's left. dividing by 2 is a very easy way to solve for x. And there we go. All right, why don't you guys try the same thing? All right, here's your guys' homework. On this first set, only create the opposite pair to eliminate. Okay, I just want you to practice that piece. So pause the video and get to where you're down to only one variable in your equation. Go. All right, I'm going to go behind you and show you these solutions now before we get to part 2. Let's look at this. I'm going to look at my equations and I'm going to say, well, the obvious thing is I can multiply a 2 to create a 6 for my x's. That's an easy way to match those up and make an opposite pair. And to do that, I'm going to need to multiply the top equation by 3. That'll create a -6, which will pair with a +6 and get what I want. Get my elimination. So I'm going to multiply that whole top equation by 3. There's a -6x when I multiply that first term, and 3 times the 3y plus 9y, and then 3 times the 8, 24. So I just multiply that top equation. Now I'm just rewriting this guy below. Okay, and we'll combine them. There's the -6x and +6x. That's that opposite pair I'm talking about. Okay, I've created my opposite pair to cancel. 9 and -2 will be a 7y. And 24 minus 24, no, turns out to be 0. That's okay. That doesn't mean we've done anything wrong. It doesn't mean there's any kind of a special case going on. We would continue solving at this point. If you divide off the 7, 0 divided by 7 is just 0. So it turns out that for this problem, y equals 0, and that is totally okay. That's a valid answer. And now we'd go back in, plug it in for x, and we'd finish. But mainly, I want you to get this idea right now of what I would multiply by to create that opposite pair, and understand that a 3 multiplied through the top equation is going to give you that opposite pair you're shooting for. All right, number 2. Let's look again. Hopefully you notice that either way, I could have made an opposite pair easily out of the y's. I could have also made an opposite pair easily out of the x's. I would assume some of you guys did it both ways. Some of you went x, some of you went y, and you know what? They're both valid, whatever you choose to do. If I was going to get rid of the y values, that was going to be what I target, then 3 needs to become 6, meaning I have to multiply the whole top equation by 2, but not a +6, because I've already got a +6 on the bottom. It's got to be a -6. So it's going to be a -2 that multiplies through each part of the equation. 0 times anything is still 0. The 3y times -2 is a -6y, and the -4 times -2 is a +8x. Copy this equation down, and I've got the opposite pair I need to make that cancellation. Those guys cancel. The 8 and -2x is a 6x, and 0 minus 18, -18. And there we go. I'm down to a 1-variable equation to solve. If you decided to go the other route, we can look at that really quick as well. Maybe you decided to go the other way. Instead of the y's, you went with the x's, which means I just need to multiply the bottom equation by 2. And since they're both negatives, it needs to be a -2. It turns out to be the same thing both ways. Didn't even notice that. And so now -18 times -2 is a +36. The 6y times -2 is a -12y. And the -2 times the -2x makes a +4x. And we can see that when we add the two together, the -4 and the +4x will cancel, leaving an equation that's only got y's and our constant. Okay, that's the idea. All right, actual or finish of your homework rather. Solve these two systems using elimination. So you're doing what we just did, create your opposite pair and cancel, but then just go the extra step and finish and solve the whole system. I will do it right behind you. Pause the video, turn it back on in a minute when you're, or 10 minutes when you're done, and see if you're correct. Go. All right, if we've unpaused, I'm going to kind of speed it up a little bit. I've talked through this about 5 times, so let's just see it done. That's the opposite pair I'm going to target as my y's. And I see if I multiply that top equation by 2, and wow, -2, I just keep coming back to that. Multiplying by -2 will make that opposite pair. -2 times 3 will be a -6x right there. -2 times -y, +2y, and the 13 times -2 is -26. I'll combine those together, -6 and 8, 2x. Cancellation, -26 and 34. I think that's 60. Nope, I'm going the wrong way. No, I'm adding those. Sorry, guys, I was thinking about distance. I was thinking about subtracting them. 8. Kind of got me there. Yep, 8. Okay. Dividing off the 2. The whole point of that was to get down to that one variable, which makes it so easy to solve. I've got an x value of 4. Pick any of the original equations, that one, or the one I created for the opposite pair. Whichever one looks easiest. I'll pick the top one of the 3. It's just got the smallest values. There's no coefficient on the y. It just looks easiest. So the x equals 4. Plugging in to solve. -12 minus y equals 13. If -y equals 1, positive y equals -1, so my solution is 4, -1. There you go. All right, second one, same thing. I'm going to look at these, and I can go either way. I could multiply the 3 to make the 6 and get an opposite pair there. I could also multiply the 2. Oh, wait. Ha ha ha. Did you notice? That's not a y. That's a constant. I'm not ready to do anything yet because I've got to rewrite my equation. I need my y's over here and my constants over here so my equation's written correctly. So 14 on the right will become -14 when I move it to the left. There's my 3x, and the -4y becomes +4y when I move it over. So I just rewrote that equation here. And so now, here's my 2 equations. I just rewrote the top one to the pink, and now I can check and do my work. And again, I can multiply the 3 to make it a 6, a -6, don't forget, those will cancel. And it does turn out I can use the y's as well. I can multiply that 2, scale it up to a 4, and make an opposite pair either way. I think I'll go with the x's. So I'm going to multiply the bottom equation by a 2. And I also need to use a negative. Wow. I swear, guys, I was not doing this on purpose. I'm not sure why it keeps coming out as -2. So -2 times -14, 28. Same thing with the 3, -6x. And with that 4y minus 8y. Copy down my other equation again. Okay, that was just copying this guy down. And now I'll go ahead and see that my pair cancels. My opposite pair, -8 and -2y is -10y. Remember, we're adding these guys together. And 28 plus -38 is -10. Which makes it really easy to see what my y is. That's the whole point of doing elimination. Look how easy things become. You end up with y equals 1. Those 2 negatives cancel. 10 over 10 is 1. So now I'm just going to plug in to finish. Any equation works. I'll just pick the top one for the heck of it. And my y value of 1 gets plugged in. Figure out what x is. Okay, this is just solving. Just regular, good old solving with 2-step. And that's -6 for a final solution of -6 1. There you go. Hope it makes sense, guys. Ask me some questions tomorrow in class if not.